All right, algebra children. Today we're going to learn about parallel and perpendicular lines. So real quick before we get started, tell me what you know about parallel lines. Yes, tell me what you know about parallel lines. Very good. That's one thing we know about parallel lines. He said they won't ever run into each other. The math word for run into each other is intersect. They won't ever intersect. That is exactly right. If they don't ever intersect, what does that mean about them? Very good, because they are lines. There's not an end or a beginning. Very good. They go on forever, ever. Say what? They are linear. Parallel lines are linear. Let me give you an example of a couple of parallel lines. So I'm going to draw an x-axis and a y-axis to start off with. What ruler? The ruler is a figment of your imagination. Let me give you a couple of parallel lines here, children. A little bit here and there. So these are parallel lines. I'm going to label them in just a second. AB and DE are parallel lines.
So they're like equal, or they're going in the same.
They're going in the same direction. They go on forever, ever, forever, ever, forever. So I'm going to put these arrows on. They don't intersect. Point D is going to be 0, -4. Point E we'll put up here is going to be 6. Huh? Making what up? The thing? You thought I was making up the thing?
You got me there.
I could never make up math. So if you're following along in the notes I printed for you, we're on page 3 here. These are our two lines, line AB and line DE. And I know they're parallel because I told you those are parallel. So as Rowdy said, they're lines. We're getting there. What Rowdy told us about parallel lines is the fact that they're parallel means they will never intersect. And the fact that they're lines means they're straight and they go on forever. That's why I have the arrows in the end. I used a ruler so they'd be straight, and you can see these lines do not intersect each other. In fact, if I were to zoom out and make this graph really enormous, no matter how long I chose to make these lines, they would never intersect. That's what parallel means. So the important thing to know about parallel lines is related to their slopes. So what we're going to do is we're going to use our old pal, the slope formula, which I will refresh your memory up here, what the slope formula is. This is how you find the slope from 2 points. And it is y2 minus y1 divided by x2 minus x. You should have that in your notes already because we've been using the slope formula for quite some time, but it never hurts to have it in an extra spot. So first I'm going to find the slope of line AB, and then I'm going to find the slope of line DE. So let's start off with AB. So the slope of line AB, I'm going to do M with a little AB there to keep it straight. The y coordinates for line AB are 2 and -6. So it'll be 2 minus -6 on top. The x coordinates are 0 and -6. So 0 minus -6. 2 minus -6 is 8. 0 minus -6 is 6. And the thing reduces to
4/3.
4/3.
Yes. Yes. Yay.
Good job.
Guys, I've spoken with Mr. Borman over at Gateway, and he is talking with some teachers now about chemistry. Okay? Just thought I'd let you know I hadn't forgotten. So we're working on it. I should hear something this afternoon.
So then let's find the slope of DE. So the points for DE, the y coordinates are 4 and -4. So 4 minus -4.
Oh, that's the point because of
6 and 0 are the x coordinates. So 4 minus -4 is 8. 6 minus 0 is 6. And that will reduce to, Lord have mercy, 4/3.
since you're going in the same direction, it would be equal.
Exactly right. Since they're going in the same direction, they have slopes that are the same. So one of the things that we can write, you said, hey, what are parallel lines? Here's our definition. If non-vertical lines are parallel,
They have equal slopes.
they have equal slopes. Why do we have to specify non-vertical? Vertical means straight up and down. Why do we have to specify non-vertical lines? Yeah, but what difference does it make? Wouldn't up and down lines also have equal slopes if they were parallel?
Yeah, but
What's the slope of a vertical line? A line to go straight up and down, what's the slope?
0? No, wait.
That's a flat line. What's the slope of a straight up and down line?
Isn't it? It does not have them.
Yeah, it doesn't have one. It's undefined. That's why we say non-vertical. Non-vertical lines have the same slope. Vertical lines can be parallel. You have two vertical lines, but they don't have the same slope because they don't have a slope. They would both have slopes that were undefined.
It'll be like just 0, 2, won't be the same.
Right, right. Okay.
I guess slide 4.
Slide 2, page 4.
Dang it.
So my question is, are these lines parallel? They sure look like they are.
The blue one have 0?
It will. Sorry, the graph is already drawn for you, but I got to draw my own, just like the Pilgrims did in the olden days. And all of our Zoomers got to draw their own too. Sorry, Zoomers. So, my question is,
The lines look parallel. I don't know, dude. One looks slightly different than
hey, we don't judge things based on what they look like.
I'm sorry.
Real beauty is found on the inside. And in this case, when we say inside, what we mean is slopes.
I don't know.
Do they have the same slopes? Well, I don't care what you think. What can you prove? Prove it. Math is not about a feeling you get in your heart.
I have a feeling that these look totally different, even though they look so similar.
I'm going to tell you the same thing that my dad used to tell me. No one cares about your feelings.
One's slightly
Okay.
tilted.
So let's find the slope of PQ. I'm going to use, we'll just call Q the y2. So it'll be like 4 minus 6 will be the y coordinates. 5 minus 0 will be the x coordinates.
Would that be 2 over 5?
Negative 2 over 5, yes. I don't think that will reduce, so negative 2/5. Makes sense that it's negative because the line's going down. Let's find the slope of RS. So the y coordinates are negative 5 and negative 2, so negative 5 minus negative 2. The x coordinates are 7 and 0, so 7 minus 0. So that gives me a negative 3 on top and a 7 on bottom. So
I was right.
are these lines parallel? No.
I eyeballed it and I knew it was
These lines are not parallel. Why not?
because
Because the
the slope is not equal.
slopes are not equal. Because they are non-vertical lines.
So I was right. And
Non-vertical.
that one was planted in
Non-vertical lines with unequal slopes. And if there's one thing we're all about with parallel lines, it's equality. What?
What are these questions?
Is it? I don't think I agree with that. I think there's just a difference between equal and the same. What you're talking about is when things are the same. That doesn't mean equal. If you are a native English speaker and I am a native German speaker, and I give both of us a test that is written in German, and my grade is higher than yours, does that mean we have equal intelligence? We were given the same test.
No, because he was German.
So if I wanted us to have an equal chance of scoring well on the test, we would not have the same test.
No.
I would get one in German and you would get one in English.
Well, we all get English because English is super when it comes to it.
If you can't read and I can read, and we each take a reading test, might look like I'm way smarter than you just because you can't read. So it wouldn't be a good, although it would be an excellent way to test our reading ability. If it was a test that wasn't over reading, probably would not be a good way to judge our intelligence. If I gave you a history test and I gave myself a history test, but I can read and you can't, I bet I'm going to do better on the test. That's the same. But if we take the same test and somebody reads it to you, now we can see if our knowledge of history is equal. Okay. These two lines that I drew for you are not parallel. I don't even need to do any math to tell you they're not parallel. How do I know they're not parallel? What did they do that automatically makes these non-parallel lines? They cross, exactly right. These two lines intersect, that means they're not parallel. These lines are what are called perpendicular. So line EF, Zane says they're perpendicular, he's right. Line EF, and now you can't tell just by looking at them that they're perpendicular. The only way you know these lines are perpendicular right now is because I just told you that they're perpendicular. And the reason that I told you they're perpendicular is so we can do the same thing that we did with parallel lines, which is find the slopes and see what's the deal with slopes of perpendicular lines. Now, before we do this, what do you already know about perpendicular lines? They're not going in the same direction, right? What else? You said they do intersect, perpendicular lines intersect. So are any two lines that intersect perpendicular? Or are they lines that intersect in a special way? Like if I drew a line that went like this, and then I drew another line that went like this, those lines intersect. Are they perpendicular? You're shaking your head no. Why not?
They're not in the same direction.
They're not, well, they're not going in the same direction. Zane says they intersect and have the opposite slopes. You're right, we're not really getting into slopes yet. I just want to know, how do they intersect? We're about to do slopes. You're one step ahead of me, bud. If they're perpendicular, they should intersect at a 90-degree angle. Intersecting at a 90-degree angle is what makes lines perpendicular. So one of the ways you can tell they're perpendicular is if somebody says these lines are perpendicular. That's really helpful. Another way you can tell lines are perpendicular is if we draw the right angle box like I just drew here. That's also really helpful. But another way you can tell they're perpendicular is from the slopes. So let's examine the slopes of these two lines and see what the relationship is with slopes. Now, Zane had a really good guess. He said the slopes are opposites. Let's find out if he's right. And if he is, we'll have to ask him to define what opposites mean. So first I'm going to find the slope of line EF. So I'm going to subtract the y's. Let's do 3 minus 7 because those are the y coordinates. And on the bottom, I'll subtract the x's. 6 minus -6. So this is going to give me -4 on the top, 12 on the bottom, and that will reduce to -1/3. So now let's find the slope of the other line, which was line GH. So we're going to use the y's. We'll do like 8 and -4. And then 0 minus 4. Oh, wait, did I get that? I did. I got that. I got the bottom backwards. 4 minus 0. That's going to give me 12 on the top and 4 on the bottom, which will reduce to
3/1.
3/1 or just 3 if you like.
Because you can divide by 4 and 4 divided. 12 divided by 4.
So Zane said opposites, and he's mostly right.
No, because one's negative.
Because one's, well, one positive, one negative is what I think of with opposites going in different opposite directions, one up and one down. If slanted lines are perpendicular, then they have, sometimes they're referred to as opposite reciprocal slopes. Like positive and negative, opposite reciprocal slopes. I believe that's the way they refer to it nowadays, is opposite reciprocal, but back in the olden days, we called them negative reciprocal, which just meant change the sign. That's the way us old people refer to it, negative reciprocal. Just means you change the sign. If it's positive, you make it negative. If it's negative, you make it positive. So far, so good? So let me turn on that for you here.
How do I measure if something is 90 degrees? Measure that.
How do you measure it?
Or like, how do I know?
You just feel it in your heart.
I don't think this will help.
Oh, or you could use the slope formula, which is what we're going to do. I recommend the slope formula. Question, are these lines R, JK, and CD perpendicular? Inquiring minds want to know.
Yeah.
Zane is right. Opposites are either, he's back on the last problem, but opposites are either the negative or positive version of that number. Cool. Are these perpendicular? And the answer is, oh, got to find the slopes. So let's do that. Let's find the slope you know because you feel in your heart.
No, I didn't know.
Oh, you did that. Okay, well, what'd you do?
So I didn't know. It's separated. NCD equals negative 4 minus 10% negative 8
Mm-hmm.
over 2 minus 10% negative 6 equals math, which is 4 is 2 negatives.
Mm-hmm.
Equals 4.
Mm-hmm.
And that would be equals to 1/2.
Mm-hmm. Nailed it. You're so smart. Your math teacher must be incredibly handsome. So now we'll do JK. Y2 minus Y1 over X2 minus X1, which is negative 2 over 1, or just negative 2.
How about that too?
Are the slopes opposite reciprocals?
Yeah.
Yes.
Yeah.
The slopes are opposite reciprocals. So the lines are perpendicular.
When's the time they can't be perpendicular?
What do you mean?
Like when the lines intersect, but they're not perpendicular. Is it most of the time you're perpendicular?
Most of the time, lines are not perpendicular.
Not even when they intersect.
When they intersect, they're usually not perpendicular. But it does happen on occasion. Now let me show you an application of this.
Wait. So when you're saying like when they're not perpendicular, is it like so you have a graph, right? And then on the right side, one goes up, and the other one goes like the side, like straight. That might be cool.
Yeah, anytime the slopes are not opposite reciprocals, but they intersect, there's not really a structure for them, just two intersecting lines.
I'll just do this.
Is triangle ABC a right triangle? And remember, if it's not a right triangle, it is a wrong triangle.
You guess that one slope.
I do, because a right triangle means what? Something is a right triangle, what does it have? What?
Oh, it's a right triangle. Yeah, it is. It's right.
Yeah, what's the certain angle it's got to be a right triangle? Yeah, it's got to, this is going to blow your minds, kids. It's called a right triangle because it's got a right angle in the triangle. I know, I was shocked too. How can I tell if that's a right angle? Well, are AC and BC perpendicular? If line AC is perpendicular to line BC, and here's the symbol for perpendicular, perpendicular to line BC, then angle C is 90 degrees.
So it has to be 90 degrees. A right triangle.
So let's find out. Let's find the slope of CB and the slope of CA. So the slope of AC is going to be y2 minus y1 over x2 minus x1.
It reduces to -1/4.
Correctamundo, as the kids say. Then let's find the slope of BC. It's going to be y2 minus y1 over x2 minus x1, which reduces to 4 over 1, or just 4.
Which is the opposite reciprocal.
Hey, they are opposite reciprocals, which means they are perpendicular lines, which means this is a right triangle. So because AC is perpendicular to BC, angle C is 90 degrees. This is a right triangle. What a relief. The voices, a little bit. They're always there. So the last thing that we're going to talk about is how can you write your own equation for a parallel or perpendicular line? Last thing we're going to do today in math for now. Find the equation of the line that is,
Draw it.
nope, no drawing this time. that is parallel to y equals negative 1/3 x plus 6 and passes through the point (1, -8). The key word here is parallel. If two lines are parallel, what does that tell us?
They're not perpendicular.
Okay, technically true. What does it tell us about the slopes?
They're
They're equal. Parallel lines have equal slopes. So our new line has a slope of what's the slope of the original line? So the slope of the original line is negative 1/3, which means the slope of the new line is going to be also negative 1/3. So in order to write an equation for a line, I need the slope and I need the y-intercept to write it in slope-intercept form. I know the slope, it's negative 1/3. Now I got to find the y-intercept. So I'm going to use slope-intercept form. To find the y-intercept. I just figured out that the slope is going to be negative 1/3. And I also have an x and a y coordinate. The problem tells me that it goes through 1, -8. So my xy is going to be 1, -8. So when I do slope-intercept form, y equals mx plus b, I can replace the m, the x, and the y with numbers and then solve for b. -8 equals negative 1/3 times 1 plus b. Word on the street is negative 1/3 times 1 is negative 1/3. What would I do next? I would add 1/3 to both sides. This would be a great time to bust out your calculator if you're not really in the mood to find common denominators. It's not that hard though. -8 would be negative 24 thirds, plus 1 would be negative 23 thirds. And that is the value of b.
I still don't know how to type in fact. I know how to type it in, but it won't let me.
So you do -8 plus 1/3, 1 divided by 3. And then on your calculator, your TI-84, press math and select fraction, and it will give you your answer as a fraction. If you don't press math and fraction, it will give you negative 7.666666666.
No, but like whenever I type in the fraction, it won't let me like stop typing. I don't know.
It won't let you stop typing the fraction?
Yeah, like it won't let
Then how are you talking to me right now if you're not able to stop typing a fraction? Shouldn't you still be typing the fraction? If you can't ever stop typing a fraction, why aren't you typing a fraction right now? busted. So there's my equation. Doesn't look like it, Brock. God bless you, my child. Hmm? Yes. No, like in church.
Get it to there's sin in that.
It's pronounced sign.
Whatever.
Terrible joke. Okay. Now, let me show you how to do a similar problem, but instead of parallel, perpendicular. Math is the holiest of all subjects. Without math, would Noah have been able to build the ark? No.
That is a good point.
I only have good points. You need math to read the Bible as well. It's filled with numbers. Genesis 7:5. If you don't know the orders the numbers go in, you'll never find it. You know the Bible has 1,058 chapters. It's a long book. Long book. Okay, so again, in order to find the equation of a line in point slope form in this case, I still need the slope. So I'd like to be able to take this equation that I was given and find the slope. There's a couple of ways to do that, but there's only one that will not crush your soul, and that is to put this into slope-intercept form. At this point, you should be relatively familiar with putting things into slope-intercept form. We would subtract the x on both sides and then divide everything by -5. So there's the slope of the line that I was given, which is 5. So the given slope is 5, or 1/5. So the new slope, the slope of my perpendicular line, is going to be the opposite reciprocal of that, which is close. She said 5/1, -5/1, or just -5. So point slope form requires us to have the slope and a point. We were actually given the point. In point slope form, it's called x1, y1. That's the point we were given, which is 2, -1. So point slope form looks like this. And we're just going to replace the x1 and the y1 with our 2 and -1. And we're going to replace the m with -5. So y minus y1, which is -1, equals m, which is -5, x minus x1, which is 2. Since our instructions were to write it in point slope form, I'm basically finished. This is point slope form, except it kind of bothers me that we have minus -1. So I'm going to do, instead of minus -1, I'm going to change it to +1. If this problem asks me to write it into slope intercept form, I would obviously have a little bit more work to do, but it didn't. It said point slope. I'm gonna leave it just like that. Point slope. And that's the way. I like it. Who has questions about parallel lines, perpendicular lines, or what it would take for you to be the coolest math teacher on campus? Step one for you guys is going to be go to a different campus because that position is filled here. I'll give you more in-depth ideas later if you want them. Any other questions about parallel and perpendicular lines? Speak now or forever speak later, I guess.